So translations of functions, bear with me, let me just repeat what we did. If you've got a function f of x is 4 to the x, to reflect it about the x-axis, it's just g of x equal negative 4 to the x. Putting a negative in front of the entire equation, that reflects it about the x-axis. We've done that with other things, polynomials and parent functions. The new thing is to reflect it about the y-axis. So in this case, if I write 4 to the negative x, so I just put a negative in front of the exponent, that reflects it about the y-axis. Okay. Now, what would it take if I've got f of x, if g of x is moving it up by 4? What is this equation? To move it up 4, what is that? It's 4 to the x plus 4. Okay. That's f of x moved up by 4. Okay. What would it take to take it and move it down by 4? 4x, 4 to the x minus 4. Okay. That takes that 4 to the x and moves it down 4. These are things we've done in the other problems that we've done. Now, what would it take to move it to the left? 3. Okay. What was different about the left and right moves? They're what? Yeah, so like plus, and the up and down, plus is up, minus is down. On the left and right, moving it to the right is what? Negative or positive? Negative. Moving to the left is... So what would it take to move this thing to the left by 3? Moving to the left is what? Yeah, so moving to the left is plus 3, okay? So that moves it to the left. You should be able to figure out what moves this thing to the right. 4 to the x minus 3. Okay. You see the difference between when the number is off by itself, what kind of move is this? Vertical, horizontal. That's the vertical move. When it's in the exponent here, these are what kind of moves? Horizontal, okay? Now, here is the biggest mistake that people make. It's when you're reflecting about the y-axis and you're shifting left and right, okay? So if you look at this, f of x equal 5 to the x, okay? Now look at g of x, okay? What does the negative in front of the exponent mean? Negative in front of the exponent means it's reflected how? Not x, y-axis. That's the new one today. Reflected on the y-axis. And what does the plus 1 mean? Moving it to the left, okay? So this has been reflected about the y-axis and moved to the left, okay? Does everyone agree with that? Now, here's where it gets a little bit tricky. If you see something like this, 5 to the negative x plus 2, okay? What you need for the y reflections is you need it like this. You need the negative in front of this entire term, okay? So when I see 5 to the negative x plus 2, I really need to think of it like this. Negative of x minus 2. What did I do to get from here to here? What is the difference here? Basically, it's factoring out a negative. So, I mean, this is negative x plus 2. This is negative x minus negative 2. It's the same thing, right? Yes. Which one? Okay. Guys, you're going to have to be able to recognize this. Negative x plus 2 is the same thing as negative of x minus 2. How do I know those are the same things? Let's distribute this. This is negative x minus negative 2. These are the same things, okay? So when you see an expression like this, 5 to the negative x plus 2, you have to write it as a negative in front of this entire exponent expression, okay? So now what does this mean? This negative means it's been reflected where? About which axis? The y-axis. This minus 2 means it's moved where? Minus 2? Come on, guys. In the exponent, these movements are what? Horizontal or vertical? Horizontal. The words for horizontal are going to be right and left, okay? So it's reflected about the y-axis. The minus 2 means it's moved where? To the right, okay? So this is reflected about the y-axis and moved to the right by 2, okay? Like what? Like that's two reflections. That's reflected about the x-axis and the y-axis. Okay. So what's new here is this y-axis reflection. Okay. So let's take a few examples. I'm reflecting from f of x, or I'm transforming from f of x equal 5 to the x. Okay. Now, if I go from 5 to the x to 5 to the x plus 1, has this been reflected about the x-axis? No. What would be my indication? A negative in front of the entire equation. Has it been reflected by the y-axis? No. What would be my indication? Yeah, instead of 5 to the x, it would be a 5 to the negative of that. Okay. Has it moved up or down? No, it has not moved up or down, right? But what has it moved? Okay, it's moved to the left by 1 unit. Okay. So that x plus 1 moved it to the left. Okay. So let's look at a few other examples here. My original was f of x equal 5 to the x. Has this been reflected about the x-axis? No. Reflected about the y-axis? No. Okay. Did it move up or down? 0 units. Okay. Did it move left or right? Yeah, right by 1. Okay. Okay. Well, my indication would be from a 5 to the x, it'd be a 5 to the negative x. I'd have a negative in my exponent. Okay. Okay, let's look at the next one. Has this been reflected about the x-axis? Yes. My clue was that negative in front of everything. Has it been reflected about the y-axis? Nope. Vertical. Nothing horizontal. Yeah, 1 to the left. Let's look at the next one. Has this been reflected about the x-axis? No. What about the y-axis? Yes. Okay. That negative x in the exponent, that's the reflection about the y-axis. Did it move up or down? Nope. Did it move left or right? No. Okay, so that one was only reflected about the y-axis. Let's look at the next one. Has this been reflected about the x-axis? Yes. What was my indication? It's that negative right there in the front. That's the reflection about the x-axis. Has it been reflected about the y-axis? Yeah. What was my indication of that? It's that negative right there, that negative x. Okay. Did it move up or down? Yeah, it moved down by 2. Okay, that's right there. Did it move horizontally? No. What is the horizontal asymptote? Y equal negative 2. Okay, so that's another question I could ask. Y equal negative 2. That is the horizontal asymptote. The next one, there was a bad page split. Okay, so there are none in these problems. Okay, so let's look at this one. See why I've got the page split going on here. So here's the one. Here's the problem that I'm looking at right here, and here's where I'm asking about it. Okay, has that been reflected about the x-axis? Yes. Okay, my indication was the negative in front of everything. Okay, has it been reflected about the y-axis? Yes. Okay, my indication there was the negative on the exponent. Did it move vertically? It moved what? Down by 4 units. Okay. Now horizontal, here's the trick. I told you this is what messes people up. So this is negative 5. You have to write it like this. That negative has to be in front of the entire exponent expression. Are these the same or are they different? What is this? Yeah, it's the same. This is negative x plus 1. This is negative x plus 1. Okay. So this means that it moved horizontally in which direction? Where? Negative 1 moves it to the right. Why is what? Why is this not still positive? Well, you have a negative in front of the entire exponent. That's the y reflection, okay? But this translation is 1 to the right, okay? If you don't do this, you're going to tempted to say, oh, it's reflected about the y, and I'm going to look at that plus 1, I'm going to tend to say it moved where? To the left. Well, when you reflect it, the left and right change, okay? So if I had something like here, and I can move it left and right, but if I reflect it, left and right become opposite of each other, okay? So what you have to do when you're looking at y-axis reflections and vertical, you have to have a negative in front of the entire exponent. So basically you factor out a negative 1 there. Okay, this is probably the hardest concept in factoring these guys, or graphing or decoding these guys. What about this one? Has it been reflected about the x-axis? Yes. The y-axis? No. Did it move up or down? Yeah, up 1, left or right? Left by 1. What's the equation of the horizontal asymptote? Y equal 1. Okay, so this is just basic decoding, and let's say 99% of that you probably could have done. Yep. Yep. Right, there's no negative in front of the x, okay? So there's nothing I have to do. If there's a negative in the exponent, it has to be the negative of the entire exponent, okay? So let's graph this last one here, okay? What I find, you've got a choice. Here's what you can do. When you look at this graph, this is the one that we just talked about. And what do we say happened? It is reflected about the x-axis. And it moved up 1 and then to the left 1. Okay. So this is what I need to graph. Now here's what you can do. I'll give you a choice, but I think I know what people want to do. You can graph 5 to the x and then do all 3 of these translations. Okay. I'm going to do it that way first, and then I'm going to just pick the points like we did a moment ago. So if I'm going to graph, what was it, 5? Is it 5 to the x? Or 4 to the 5 to the x. So if I graph 5 to the x, okay, 5 to the x, 5 to the 0 is 1, 5 to the 1 is 5, 5 to the negative 1 is 1/5, okay? So this is what 5 to the x looks like. Well, I have been very consistent about this. I have picked where this thing is 0, and I picked the 2 numbers on either side of that. So 5 to the 0 is 1, 5 to the 1 is 5, 5 to the negative 1 is 1/5, okay? Now, if you're going to do the translation, what does it mean to reflect this about the x-axis? Where does this point go? It comes down here, right? Okay. And then what does it move when I move it up 1? It goes here. What does it mean when I move it to the left 1? That point goes right here. What happens when I reflect this one? It goes here. I move it up 1 and to the left 1. That goes right there. Okay. And then if I look at this point at, what is that, 1/3? It comes down here, okay, by 1. Take it up 1 and over 1, and you see it going right there. So in this case, to graph this guy, you're going to see something that looks about like this. Yeah. So now, that's one way of doing it. Some people swear by this method, okay? What I tend to do, because it's what we did the other day, and it can work every time, is just, let's pick 3 points, okay? So I need to graph, what was this guy? 5, -5, So negative 5 to the x plus 1 plus 1. So I want to pick points. I'm going to pick the first point. Where does this equal 0? When does that happen? Yeah, when x equal negative 1. Okay, that's one of my points. Okay, what are the other 2 points I'm going to pick? I'm going to pick the points on either side of that. Okay, and now I'm just going to substitute these 3 values in. Okay, so negative. So let's work with this one. Negative 5, negative 1 plus 1 plus 1. What is negative 1 plus 1? 0. So this is negative of 5 to the 0 plus 1. What's 5 to the 0? 1. What is negative 1 plus 1? 0. So negative 1, 0. Okay. Let's plug in a negative 2 here. This is a negative of 5, negative 2 plus 1 plus 1. What is negative 2 plus 1? Negative 1. So this is negative of 5 to the negative 1 plus 1. What's 5 to the negative 1? It's 1/5. Okay. So this is negative 1/5 plus 1. What's 1 minus 1/5? 5/5 minus 1/5 is 4/5. And then 0. What is negative of 5 to the 0 plus 1 plus 1? What's 0 plus 1? 1. So 5 to the 1 is 5. So this is negative 5 plus 1. What number is that? Negative 4. So I graph these 3 points. What is my asymptote here? Y equal 1. Okay. Asymptote is y equal 1. I graph negative 1, 0, 0, negative 4, and negative 2, negative 4/5. So somewhere right here. So you see this guy happening. Okay. So it's a little bit more involved than what we did the other day. Which do you prefer? I feel like people prefer this method. It works for any one of these. You pick 3 points and you know what it's going to look like. You have to be very careful when you're substituting these values in. Okay? Yes. Right here? Right here? Negative 4. Okay. So, like I said, the big thing here is to be very careful with your arithmetic. So what you should be able to do now, you should be able to look at any translation. So you look at something that starts out like this. This is what we started with yesterday. Okay? And you're going to get something that looks complicated like this. Okay? The plus or minus in the front tells you whether it's rotated about the x-axis. The plus or minus in the exponent means whether it's reflected where? Not the x, the y-axis. The plus or minus on the number at the end tells you what? This number on the end. What does that control? No, the asymptote, but the movement of the graph. This number moves it where? Up or down. This number right here, this C, that moves it where? Left and right. Okay. So the only thing that's new is this reflection about the y-axis. Okay. So let's look at this guy. So my original function is 3 to the x, and I'm trying to graph this guy right here. Okay. Has it been reflected about the x-axis? Yes. Okay. Did it reflect about the y-axis? Yes. Did it move vertically? Yeah, it moved up 2. Did it move horizontally? Where did it move? To the left by 1. Okay. Now, how do we graph this function? Okay. So I'm not going to graph 3 to the x to do the translation. I'm going to do the way I just did it a moment ago. So I need to look at negative 3, negative x plus 1 plus 2. Okay. I need to look at where that exponent is 0. Where does x plus 1 equal 0? Yeah, x plus 1 equals 0 when x is negative 1. So I need to look at negative 1 and what other points? Yeah, negative 2 and 0. These are the 3 points I need. Okay. So now it's just a matter of me plugging in to this equation, okay? So let's just start here at negative of 3 to the negative 2 plus 1 plus 2. What's negative 2 plus 1? Negative 1. So this is negative 3, negative 1 plus 2. Okay. What's 3 to the negative 1? No. 3 to the negative 1. 1/3. Okay. So this becomes negative 1/3 plus 2. What's 2 minus 1/3? 2 minus 1/3. 2 minus 1/3 is 1 2/3. Okay. I know this is the end of the day. So this point is negative 2, 2 1/3. That's my first point. Okay. So where's the asymptote here? Y equal 2. Okay. Let's plug in the next value here. So this point gives me what, 1 2/3? 2 2/3. Sorry, you guys. 2 minus 1/3 is 1 2/3. So this point right here is 1 2/3. 2 minus 1/3. Okay. So the next one is going to be what? So that's this first value here. This next one is going to be negative 3 to the negative of negative 1. Wait, I made a mistake here. Did I do? Yeah. Let me back up. Sorry, guys. Let me back up. Let me erase all of this. I made a mistake with my parentheses. When I was substituting this in, this is negative 3 raised to the negative of negative 2 plus 1 plus 2. I have to plug it in just like it is, okay? What is negative 2 plus 1? Negative 2 plus 1. Negative 1. Okay, so this is negative 3 to the negative of negative 1 plus 2. What's negative of negative 1? 1, right? So this is negative 3 to the 1 plus 2. Okay. What's 3 to the 1? 3. 3 to the 1 is 3, right? When you stick a negative in front of it, what do you get? Negative 3. Negative 3 plus 2 is? What's the question? Yeah, so in this case, I don't have a negative exponent. So what happens, this is what? This is negative 3 plus 2. This number is negative 1. So my point, that first point is negative 2, negative 1. Okay. This one? This is if you wanted to graph the original and then do the translation. You guys said you would rather do the 3 points. Okay, so negative 2, negative 1 is right here. Okay. And now let's pick what happens at negative 1 here. So let me get a little bit more space. So at negative 1, I'm going to have negative 3 of negative 1 plus 1 plus 2. What's negative 1 plus 1? 0. So this is negative 3 to the 0 plus 2. What's 3 to the 0? 3 to the 0 is 1. So this is negative 1 plus 2, which is 1. So this point is negative 1, 1. So negative 1, 1 is that point right there. Okay. Now, I can plug in the next point, but do you sort of know what's happening at this point? Which way do you think it's going? Well, I mean, if it goes from here to here, where do you think it's going to go next? Yeah. I mean, at this point, I know that it's doing this, okay? No, I think you're good at that point, you know? If you've got the asymptote, you've got these other 2 points exactly. I think you're good at that point to know this is what that graph looks like. Okay, like I said, this is where it gets a little bit hard. It's just you've got to be very conscious of the arithmetic and what's going on to make that work. The other way of doing this is to graph the original function 3 to the x, flip it over the x-axis, the y-axis, move it up 2 and to the left 1. Sometimes people have, if you think it's a little bit hard to substitute these values in, that's 4 different transformations for every point. So sometimes people get a little bit lost in doing that. Okay, but I think you can handle what we're doing here as a repetitive exercise. What is the range of this function? Yeah, so it's negative infinity, infinity for the domain. Negative infinity, it's negative infinity to 2 is the range. And the asymptote is y equal 2. Pardon me? It's what? Yeah, any number to the 0 is 1 except for 0. Yep. Okay. So that one didn't feel exactly wonderful. Okay. Let's do another one of these guys. So graphing negative 2 to the x plus 3 minus 2. Okay. In order to graph this, what I'm figuring out, where does x plus 3 equal 0? When x is equal to what? Yeah, this means that x equal negative 3. So I'm going to test negative 3, and then what are the 2 points on either side of that? Yeah, negative 2, negative 4. So these are the points I want to try. Negative 4, negative 3, and negative 2. Those are my x values. Okay. If I can find out what's happening at these points, I'll know what this graph looks like. What is the asymptote here? Negative 2. Okay. So here's my asymptote. So this thing is either going to be above the line or below the line. Okay. So I can sort of figure out what's going on. Let's start with this number right here. So let's just see negative 2 to the negative 3 plus 3 minus 2. What's negative 3 plus 3? 0. So this is negative 2 to the 0 minus 2. What's 2 to the 0? 2 to the 0 is 1. So this is negative 2 minus 2. What's negative 2 minus 2? Let's go with negative 4, right? Oh, sorry. My mistake. Sorry, guys. This is where you can run into, let's back up here. So negative 2 to the 0 minus 2. So 2 to the 0 is 1. This is negative 1 minus 2, which is, Michael had it, minus 3. So negative 3, negative 3. So negative 3 is right here. Let's look at what's happening at this point. This is what? Negative 2 to the negative 2 plus 3 minus 2. Look at that exponent. What's 3 minus 2? 1. So this is negative 2 to the 1 minus 2. What's 2 to the 1? 2. So what's negative 2 minus 2? No? Negative 4. So this point is negative 2, negative 4. Okay. Pardon me? Can you see what this graph is doing now? Yeah. So this one you can tell this is what it's doing. If I look at the original, has this been reflected about the x-axis? Yes. What about the y-axis? No. Okay. Did it move vertically? Yeah, it went down 2. Did it move horizontally? Left 3. Okay. Okay. And we got another one here. The range of this, guys, what is the range on this one? Negative infinity to negative 2. Okay. And then what you see here was just me, the points that I picked, okay? It's just walking through that. and then that takes you into the homework. Okay.